So now you have to apply this concept to the four faces of your control volume, horizontal face. Okay, so you have a face on the eastern side, western side, northern side, and southern side, and only the wind stress components parallel to the face matter, because only these components can create Ekman transport that move across the face. Again, here's one example shown. It's shown for the southern hemisphere, and you know that in the southern hemisphere, the Ekman transports are to the left with respect to the wind direction. Okay, I've also used another important relationship here, namely that the Ekman transports are proportional to the magnitude of the wind. So if you have a given wind stress and you draw an arrow, yeah, of a certain length, okay, and you draw a corresponding arrow for the Ekman transports, if you double the wind stress, you also can double the arrow for the Ekman transport. So this is how you can actually work out the relative magnitude of the Ekman transports without actually using a formula to calculate. It's a little trick. Okay, so what's shown here is a situation now where I give you certain wind stress components. Okay, so you have the westerly, easterly components along the northern and southern faces, or the northerly, southerly components along the eastern and western, and you draw the corresponding Ekman transports, and then you look at it. And in this example, there's just focus on the east and the eastern and western face. You can see the arrows are the same length. Okay, on the left side is some volume coming in through the Ekman layer, the same volume leaving. So in the X direction, nothing is happening. Everything happening in the Y direction, where there is an export away from the control volume in the north, and the same transport away to the south. So the control volume is losing mass, and it's a deficit in volume. And this is what we call Ekman suction. And it is balanced by an upwelling of deeper water. Okay, so this is how you can apply the control volume concept to work out Ekman pumping or Ekman suction in the ocean. So I hope that this consideration, this discussion of control volumes, helps you a little bit in the understanding of the marine sciences and oceanography. It's an important concept.